Okay, AP Calc AV, Unit 4, Day 7. It's homework, office hours. So, with the function f given, arrange the following quantities in ascending order. 0 and 1 are just values. Prime means the slope at 2. Kind of sketch a tangent line. Slope at 3. Now, I would say that these are definitely less than a slope 1. Slope 1 would be like a 45-degree angle, right? That'd be like this. So I'd say ascending means smallest to biggest. These are positive slopes. So I'd say 0, then the slope at 3, then the slope at 2 is steeper, and then the value of 1 is more than the slope at 2. So this would be ascending order, smallest to greatest. Okay, refer the graph of the function k between which pair of consecutive points is the average rate of change of k the greatest. So average rate of change is the slope of the secant line between the endpoints. So it says which of these is the greatest. So we could just draw it. It'd be that, it'd be that, it'd be that, it'd be that. Greatest, I mean, either it's a tie or it's just slightly different. It's either A and B or C and D have the greatest slopes. Therefore, the greatest average rate of change, which is slope. Rate of change, that's slope. Okay, between which pair of consecutive points is the average rate of change of k closest to 0? Well, the flattest would be BC, closest to 0. Okay, next one's match points labeled on the curve with the given slope. So we're trying to, this one looks like 0. And that's probably E. This one is definitely negative. This one's negative, but not as negative. So the more negative one is probably F. The less negative one is C. Then we have a positive slope, and we have a barely positive slope, another positive slope. So I would say this one's probably the steepest positive slope. So I'd put D here. And the least steep positive slope would be A, and the one in between would be B. So we're just looking at the slopes and comparing them to each other. Okay, for the function shown at what labeled points is the slope of the curve positive, negative? Which labeled point has the greatest slope? Which has the least slope, most negative? So, say this is 0. That's positive. That's negative. That's positive. That looks like 0. That's negative. So positive slopes, I would say, would be A and D. Negative slopes, I would say, would be C and F. Greatest would be the biggest positive one would be A. Least steepest negative one, I think, would be F. So there you go, right? Number 5 says for the graph of y equals f of x shown, arrange the following numbers in ascending smallest to greatest order. So this kind of reminds me of the first problem. Slope of curve A would be that. Slope of curve B would be that. Slope of curve C would be that. So those are getting smaller and smaller. Slope of 1 looks like it's kind of in between. The slope of the line AB would be this one, right? And then just the number 0 and the number 1. This looks like the slope of 1 right here. So it's just kind of a reference. And so I would say 0 slope would have to be the smallest because there's no negative slope. So 0. And then the least steep value, I think, would be C, or answer C. So I guess we're supposed to be doing answer E, answer C. And then let's say B looks less steep than either of those. So I'd go with B. And then I think A is going to be the most steep. So I'll put that last. So now it's just AB and 1. And I'd say 1 is steeper than AB. So AB is going to be next. So that's D, and then 1 is F. So that would be the correct order, ascending order. Okay. All right. All right, we could write. Okay. The back is an opportunity to sketch a bunch of derivative graphs. So now the ones I give you in the lesson were piecewise, which maybe have their benefits or the negatives. These graphs are mostly all look differentiable, so their derivative graph should look nice. So this is a constant down to over 1 slope. The slope is always -2, so that's going to be this. It's a horizontal line for the y prime graph going through -2. The next one, I identified the zero slope. So, and that's going to be solid dot because it's nice and smooth. And it's definitely positive over here and negative over here. And you know, it's not, it's getting steeper and steeper and steeper. So it's probably getting steeper and steeper and steeper like that. And on the other side, it's zero and it's slowly going negative, but then it's getting steeper and steeper and steeper. So it's going to probably be like concave down, something like that. Concave up to concave down. This one looks kind of like a trig curve. So you might not be surprised that the answer looks like a trig curve. Remember, like halfway between these should be like right about here. You probably have a slope of like 1. Right? Slope of 1, slope of -1, about the same distance over here. So the graph should be a smooth graph. So something like that. All right, next one, slope is 0 here. And then it looks like the graph sort of goes towards a slant asymptote, which is going to be a horizontal asymptote on a graph. So what's that slope? I mean, can you like try and get a couple good values? Maybe, I don't know. Are there any good intersections? Maybe up 1/3, like 1/3. So that means that's going to be a horizontal asymptote in this graph because the slopes are going towards y equals 1/3. There's 0 here. They're positive, then negative, then positive. So there's a little negative. Now this one's approaching 1/3 from values that are less steep than 1/3. So it's going to be from the bottom here. So there's probably some most negative slope, you know, somewhere around here. Maybe it's like -1. So that would line up to a little valley. Then you get some of these positive slopes over here, but it's negative from here to here, and then it goes positive. There must be some steepest value around here. Maybe that's like up 2/1. So that's going to be a peak. And these should be smooth graphs, like I said, because original graphs are smooth. Then it approaches 1/3 from values that are steeper than 1/3, right? And they're coming down to 1/3. So something like that. Okay. Next one, slopes of 0. Should line up with those. Some highest positive slope of maybe, maybe 1. And then it goes negative, and then it goes negative and more negative. So maybe something like this, where it's getting more and more negative, quicker and quicker. And by the way, the derivative of this looks kind of like a cubic, right? And the derivative of cubic would be 3x squared, which would be a parabola. So this is an upside down cubic, gives you upside down parabola. So that's not really a surprise. Zero slope, maybe like zero slope. So 0 and 0 around here. So we have positive slopes, so it's got to be up here, and then we have negative slopes. Most negative slope might be like -1. And so the graph kind of looks like this, and then it gets positive and gets steeper and steeper and steeper. And then for this little chunk, it's negative, and it hits its most negative one. Then it slowly comes back to flat, 0. And then it goes negative again. So maybe something kind of like this. Something like that. And by the way, this looks like an upside down quartic, x to the fourth. And the derivative of x to the fourth, negative x to the fourth, would be -4x cubed, which would look like an upside down cubic, which just looks close to an upside down cubic. Okay, last one, 12, 0 slopes. It looks like it's approaching a flat slope, right? So I think that we're going to have a horizontal asymptote, y equals 0, and then it's negative here. It's almost kind of full. It's kind of constant. It looks like down 5/1 or something. So maybe -5. And then it kind of, and then it does these real quick. So it's going to go maybe something like this. So there you go. I mean, these are just rough sketches, so not perfect, but it's pretty good. So there you go.